This video will provide an overview of how we have built upon the project from last fall that measured shunt effectiveness in hydrocephalus patients. We took the successes of last year's project as well as stakeholder needs to create a new and improved measurement tool. This project is sponsored by the Penn State College of Medicine. Our stakeholders are Dr. Elias Rizek, a neurosurgeon at Penn State Hershey Medical Center, and Dr. Gregory Lewis, an associate professor at the Penn State College of Medicine. Hydrocephalus is a neurological disorder in which cerebrospinal fluid, CSF, builds up in the deep hollow cavities of the brain called ventricles. This causes the ventricles to expand, placing excess pressure on the brain tissues. The current treatment for hydrocephalus is the surgical replacement of a shunt, which drains excess fluid from the ventricles into the abdominal cavity. The major issue with these shunts is that they have a high failure rate, which could be contributed to problems such as blockages and fractures. If a blockage occurs, the shunt needs to be replaced. The previous group chose to utilize a motor-driven system that pushes saline through the syringe. Their project was connected to the wall, which is something that may not be feasible in an operating room. After conferring with our stakeholders, we decided to remove the motor in order to simplify the design and better align with fluid dynamic properties, as well as the mechanics of the manometer. Our stakeholders wanted a pressure sensor included to ensure that the flow was being calculated correctly. However, after consideration and calculations, we determined that this would be unnecessary because the change in pressure is relatively negligible as long as the physician uses the same amount of fluid each time. Our project works similarly to that of last year's project. The operator must fill the syringe with saline to the desired constant amount. It is recommended that the tube is primed before taking a measurement. The user will then press the measure button and watch the average flow rate appear on the LCD screen. The user could then reset the LCD screen before taking another measurement. Our project was tested through multiple different blocked shunts to ensure that the design shows lower flow values for shunts that are more blocked. This product is battery operated, so it is recommended that the user unplugs the battery after every use to conserve battery life. The physician should record the flow value after the shunt is placed so that they have a value to compare it to when they suspect it to be blocked. Overall, our product to measure shunt effectiveness is a modern-day solution to a currently outdated and inefficient practice.